Yeah.
So the negative exponent rule says anything to a negative exponent is the reciprocal. It doesn't make it negative, it just reciprocates it. So when you multiply the coefficients and you add the exponents with like bases. You cannot end with a negative exponent in your expression. You may not end with a negative exponent in your expression. Stop. So if I'm looking at this example here, we do 2 times negative 3, and when you multiply, you add the exponents. So I get negative 6x to the negative third, but can we keep a negative 3 in there?
No.
Okay, you need to make sure you realize these are different pieces. This is a negative 6, and this is an x to the negative third. First of all, a negative number does not mean a negative exponent. Does negative 6 have a negative exponent on it?
Yes.
No.
Where's the negative exponent that's on it? Right. 6 has an exponent of 1 on it. So that is not going to move anywhere. That's staying in the numerator. But you guys notice that x to the negative third has a negative exponent. We're not allowed to have a negative exponent, so that needs to move to the denominator. So we're left with negative 6 over x to the positive third. Because when you reciprocate it, it switches the sign. Okay, do you guys notice how I boxed each of the pieces? I'm going to do a lot of that today so you guys don't treat the numbers with the same exponent. This exponent of negative 3 is only for the x. The 6 has an exponent of 1 on it, okay? So we have to be very careful there. Bless you. With division, you reduce the coefficients and you subtract the exponents with like bases. So you're going to subtract the exponents with like bases. Remember, you cannot end with a negative exponent in your expression.
That wasn't.
So if we're looking at this example here, what goes into both 5 and 10?
2.
Okay, I know why you got 2, but what number actually goes into both of them?
5.
5. So we divide top and bottom by 5. When you divide, you subtract the exponent. So I have a 1 over 2. And I subtract negative 2 minus 3. Numerator minus denominator pulls that base up to the numerator. So that gives me x to the negative 5th over 2. The exponent on the 2 is a positive 1. Our pieces are this and this. Does the 2 move? No, it's fine where it's at. It has a positive exponent, so the 2 staying in the denominator. How about the x to the negative 5th? Will that move?
Yeah. Yep.
Yes, it needs to move down to make the exponent positive because you're not allowed to have a negative exponent. What's left in the numerator?
1.
Nothing's there, you put a 1. All right, so look at that and see what questions you have before we do the next one. Before we do some examples, I mean. Stop.
Can you?
I'm going to take that from you.
Okay.
Just stop.
Stop it. Fine.
That's going to go against you, too. You may not make comments across the room, but anyway, just because you can't talk to him doesn't mean you can talk to other people. No, it won't. I warned you now. Okay. Which rule is happening on this slide here? It's the product rule, which means you. So we're going to be adding the exponents. So we look at this and we multiply 5 times 2. The x's are separate here. We add the exponents. So, Kaylee, we're adding x to the...
Hold up. Give me a second. To another x.
What are the exponents on the x?
-4.
Plus.
Excuse me.
Good. Does y have anything to add to?
No.
No, so we just move that down. 5 times 2 is 10. -4 plus -2 is -6. Y to the third does not change. So remember, each one of these are its own pieces. Each one of these are its own piece. So we have to look for negative exponents on all of them. Is the exponent on 10 negative? No, it has an exponent of +1. So that's going to stay in the... It's in the numerator already. X to the -6, Jordan. Does that stay or move? Where is it going to move to? And what happens to the exponent? When you move it, it becomes positive. So that's x to the 6th. Jack, y to the 3rd. Is that going to stay or is it going to move? It will stay. So we have y to the 3rd there. And that is our final answer. Okay, there's a lot of talking happening that needs to stop.
It's not being fun.
What, Jordan?
So the only time that it goes to the denominator is because it's negative?
Okay, so it can go, yes, but I need to clarify there's other cases too. So like if it's negative in the denominator, it will move to the numerator, it being the exponent. So if the exponent is negative in the denominator, the whole entire thing will move to the numerator. If the exponent is negative in the numerator, it moves down to the denominator.
Okay.
Does that make sense?
Yeah.
And we'll look at more of those types of problems like as we do the quotient rule. Okay, so,
Negative goes to the bottom, positive goes to the
but only negative exponents. So be careful because like negative, like the next one there, 3 is negative, right?
Yeah.
But that's not a negative exponent. We've never, like when you've had -12 before, you've never written that as 1/12. You know it's just -12. So be careful that you're only looking at it in terms of the exponents. Does that make sense? Okay. So, shh, please stop talking. We have a -3 and a -4. Or a -3 and a 4. So we do -3 times 4. Mike, what are we going to do with our a to the -1 and a to the -3?
Add up.
Add those exponents. Good. And then, Riley, what are we going to do with b to the 3rd and b to the -4th? Add those. So we then simplify. -3 times 4 is -12. A to the -4th. B to the -1. Remember, each one of these is its own piece. Each one of these is its own piece. So make sure you are looking at each one separately when we go to move them around. What is the exponent on the -12? 1. And is that positive or negative?
Positive.
That's positive. So that means it's going to do what then, Kaylee? It's going to stay in the numerator. So -12 stays. Jayla, what are we going to do with a to the -4th? And what happens with that exponent? And Justin Powers, what will we do with b to the -1? Move it to that denominator, and it would be b to the 1st, so I'm not going to even write that exponent there. If you did, I would not mark you wrong. So look at that and see what questions you have for me.
That makes it not talk.
How come you put 12 down there and make it positive?
Okay, remember you have to focus on the exponent. Is the exponent on the 12 negative? 12 itself is a negative number, not the exponent. Does that make sense?
Yeah.
We don't, coefficients are allowed to be negative. You've had negative numbers since you learned them in middle school. Okay, so those are allowed. Okay, so we start here. We multiply -3 times 2. Connor, what do I do with the x's, x to the 1/3 and x to the 1/4?
Jana Zoran signing out of attendance.
Oh, no.
You're such a comedian.
How did you get way back?
Buddy, he always tricks me up when I'm.
There's a random sheet of paper stapled to it. It's actually not a packet. So here you go. They're all like that, just so you guys know. Because there must have been an extra sheet like when we sent it in.
My pen.
I mean, it's stapled already. I'm not going to go through. Okay, Mike, was I talking to you? Or was I talking to Connor? Connor, okay. What do we do with the X's? We don't multiply them. When you multiply, you...
Bye, we're gonna miss you.
Bye, Dana.
I got a pair of underwear.
Okay, what do we do with the Y's there, Josh?
You add them.
We are going to add -1 plus 3. That's not even -1. Okay, so -3 times 2 is -6. What is 1/3 plus 1/4?
7 12.
And -1 plus 3 is 2. So we look at each piece separately. So if we're looking at each piece separately, what power is 6 being raised to? Is that a negative or a positive exponent?
Positive.
So that's going to stay. How about here?
Positive.
Stay?
Positive.
Positive. So do we change the answer for this one?
No.
Nope, this is -6 x to the 7/12 over y, or not over y squared, times y squared. Justin.
Gotta yell.
Numbers that you always multiply, that'll always be on the top because it's always going to have a positive.
We're going to look at some negative exponents either, maybe not today, but it might be tomorrow where we're distributing in, and we'll be doing that. Okay? So I don't know if any of them today have that happening. It doesn't look like any of them today have that happening, but tomorrow they will. All right, Brian. So I multiply -9 and -3. What do I do with a to the 4th and a to the -9th? You add the exponent. So I have 4 plus -9. Alyssa, what do I do with the b values?
Oh boy.
You gotta add them.
-13 plus 6. Okay. So I get 27. A to the -5th. B to the -7th. Good, thank you. I was struggling there.
That's the answer?
No. Why is this not the answer?
Oh, there's a negative exponent.
There's negative exponents, which is not allowed.
I got
Is 27 being raised to a negative exponent?
No.
No, so that is going to stay. Emma, what happens with a to the -5th?
It goes on the bottom and becomes a to the positive 5.
Good. And Tanari, b to the -7th moves or stays? And it becomes b to the
7.
+7. Okay, before we move on to the next slide, what questions do you have on this slide?
So the negative exponent's in the number that it's on at the bottom.
That you
That
put
makes sense.
the negative exponent in its base.
Yeah,
So its
that
base is typically a variable. It can be a number too, though. Right now, we're just dealing with its bases. Numbers will be a part of the base tomorrow. Uh-huh. All right, let's look at some quotient rule ones. Let's look at some quotient rule problems. No, you're on the right page. I was looking to see how many problems there were. Okay, with the quotient rule, what do we do with the exponents? Okay, Blaine, what do we do with x to the -2nd and x to the -3rd?
Subtract that.
So you do -2 minus a -3.
So then you positive.
We will deal with that in a second. And Colin, with the y's we will do,
We will also subtract them.
which is,
-2.
no,
Oh,
tell me,
Oh,
You're
4
right.
minus 6.
you're right with the answer.
Yeah, ready up.
So this becomes a positive. So you have -2 plus 3, which is 1. I'll answer your question in a second, Connor. And y to the -2nd. Just let me finish this problem here. We look at our two pieces here. Cassie, I'm just trying to think who I haven't called on. Cassie, what would my final answer be then?
X will be the
X over y squared. Perfect. Good job, guys. Okay, guys, we are getting a little antsy. Please stop. What was your question, Connor?
I was gonna ask if I could congratulate Colin. But that's
Yeah, no, that's a distraction and it causes issues. Yeah.
So, for the answer that you get there, you just flip it in order to change it from a negative exponent to a positive.
You don't, I wouldn't say flip the whole thing. You only flip the base that's raised to a negative exponent. So, like, you see how we kept x where it's at? Because it doesn't have a negative exponent, but yes, you move, depending on where it's at. Since this is the numerator, technically, it's moving to the denominator. If this had been in the denominator, it would move to the numerator. Okay. All right, guys.
Grace her up. My bad.
So, RC, what goes into both 15 and 5? Bigger. You got the answer already. That's what you did. Okay, so we get 5 over 1. Lexi, what do I do with the x's?
Subtract them.
So what are you subtracting?
A half minus 1/5.
Oh.
And what are we doing with the y's there, Jayla? What are you subtracting? Minus what? Perfect. Jayla says that there's no exponent there, so it has an exponent of 1. That's why she's subtracting 1. That was perfect. So we have...
Is it 1/3?
Hey, Miss Brady, I have another question.
What?
3/10.
What are the exponents on
1/2 minus 1/5.
Okay.
What is it?
3/10.
And y to the...
1/3.
Okay, what is my final answer for this problem? Why?
Because there's no negative.
We don't have any negative exponents. This 5 has a positive 1 exponent on it, which means we do not have to switch it, and we know that our exponents are positive, which means we get to just stay where we're at. Yes, Mike?
Alright, so if that was 2/10. Alright, so this is Indian. Okay, he goes to...
No. I'm going to stop you there. Good try.
It takes a few seconds.
Go ahead.
How come you square some of them off, but then you do the cloud around time?
It's a good question. I was wondering why I was doing that too.
I don't know if it
I'll
was
tell you later. I know you're...
Yeah, it was secret code. That's it. I wish it was a secret code, but I'm not that cool, so... Okay, Tanari, what goes into 8 and negative 12?
4.
So we're going to divide top and bottom by 4. And we need to realize that a negative number should not be in the denominator, so we're going to move the negative up. So I'm going to do negative 2 over 3. I just moved the negative up. You're not supposed to keep negatives in the denominator. If you do, I will not mark you wrong. Mathematically, that's incorrect, so I am not going to write it on this board, but if you do it, I will not mark it wrong. Okay. Let's see here. Cassie, what do I do with the x's?
Hey, you squeak on her.
Please stop.
Quit that.
It's not me.
You just said I was
I
you.
was kidding.
Wait, there's 2 of them.
Hearing aids are going on.
1 second. You're fine, Cassie. Please stop. So we have x into the negative 6 minus a negative 4, which I think where you got the adding from. And then, or maybe you just said adding, I don't know. Josh, what do we do with the y's? So we have y to the negative second minus a negative 3. Does z have anything to go along with here, guys? Z is just going to stick where it's at because it really doesn't have a friend to move it around with. Poor guy. Okay, so we get 2 negatives make a positive. So that is x to the negative. 2 negatives make a positive, so that is y to the...
What power?
And we just leave our z. Okay.
She knows
What is my final answer, Riley? In the numerator, what do you have and what do you have in the denominator? What's in the numerator? Does this stay? It has a 1 as an exponent, so does it stay? Yeah, so negative 2. What else is in the numerator? X wouldn't be in the numerator. It has a negative exponent. And? So it would be negative 2yz over. What's in the? Does this 3 move? It has a positive 1 exponent. Does it move? No, so that's 3, and then you have what else in the denominator? What happens with this x to the negative second? So what's in the denominator? But you moved it, so would the power be negative anymore? Okay.
I'm not doing that.
Give me it. I'm done. I'm trying to help people out, and you're just messing around. And it's really frustrating. Does that make a little bit more sense, Riley? Or no? So you just need to go piece by piece. So this has a positive exponent, so it stays. Negative exponent, so it moves and becomes positive. The movement, the reciprocal action of it is what makes it positive. These are both positive, so they stay. 3 has a positive exponent, so it also stays where it's placed. Okay? So that's kind of what you look at is each one of those pieces. All right. Justin, Crater, what goes into 48 and negative 6? What goes into 48 and negative 6?
6.
Technically, 6 goes into both, so 48 divided by negative 6 is negative 8.
Oh, 18. Sorry.
Okay,
I did my box and
Connor,
Oh, dear.
x to the 6th over x. What do we do with those?
Also,
You subtract them.
And what's the subtraction that you're going to do?
6 minus 1.
Good, 6 minus 1. Grace, how about y's? What do we do? What are we subtracting? RC, how about the z's? So right now we don't have anything in the denominator, and that's fine. Jordan, what's my final answer? Yep, so what's in the numerator? All over z. Very good. All right, questions on that slide? We have 4 more examples, so let me know if you are confused.
That one is too long.
Tanari?
don't we all?
So I wouldn't put
You
one
usually,
in front of it.
it needs to be negative, so you had to have that negative somewhere. Usually you keep the negative in the denominator and just make the 8 negative. But if you did that, I would keep that. That's it. All right, so this next one here. Emma, help me out with this one. What would you do first? Okay. Keep going.
So like, is it the same thing like exponents?
We're doing the same rules. It's the quotient rule here. Just tell me what you would do first. I don't care what you personally would want to do first.
Probably divide by 5.
So you're dividing numerator and denominator by 5. Good. So that's negative 4 over 5. Now what? Quotient rule is to subtract. Remember, you guys have a quiz on Friday, so you need to know those rules.
I don't like
Does y to the negative first subtract with z to the third? Are those like bases? So we have y to the negative first and z to the third. Don't move yet because they don't have anything to move with. So we have negative 4, x to the 0, y to the negative first over 5z to the third.
On that first part, is that a z to the 5?
Yes. Okay, Emma, we're not done yet. What is my final answer?
Wait, why is it z to the 3?
Negative 4.
Wait, there's only one. I don't know.
Negative 4 stays.
And then x to
Anything to the 0 power is.
1.
So that goes away. Okay, then what?
Still up there, and then y to the negative 1 goes to the denominator.
What else is in the denominator with y?
5 and z to the third.
Perfect. So this is negative 4 over 5y z to the third. You weren't here yesterday and you were able to do it. So that's good.
I'm so proud of you.
What's wrong?
So when it's like x equals 0, does it matter if we write like when we're solving it?
This is technically 1. So negative 4 times 1 is negative 4. So you don't write it. It needs to go. What? Excuse me.
Just kidding. Never mind. I'm subtracting the y.
Yeah, and that's a good point. So I think a lot of you started to think that you needed to subtract these two because they were lined up with each other, but one's the base of y and one's the base of z, so be careful there. Okay. Connor, tell me what you would do first with this next one.
You can't divide by
So 5 stays, good.
Yeah.
How about the x? Is there anything to do with the x yet?
No.
Okay, that stays. What can you do now?
You subtract the y.
So negative 7 minus a negative 5, okay.
Yeah. And then the z is still there.
Okay, so do you see how the x, the z, and the 5 don't have anything to compare with right now? So they're stuck. So right now I have x to the negative 4th. This becomes an addition. Y to the negative 2nd over 5z to the negative 5th. So Connor, you're going to tell me what the final answer is now.
Oh god. The x would like go to the bottom because
Okay.
it's negative exponent, and so would the y.
And those both become positive exponents when you do the reciprocal. What else?
And then wait, we're not done?
We haven't done anything with these things
don't
yet.
just don't.
But z is negative.
Oh, so then it goes.
So we were talking about this, I think maybe Justin, you asked this question earlier. So do you see how the z is negative in the denominator? So to make it positive, it goes up instead. Or maybe you asked it, Jordan. I can't remember which one of you. Somebody made a comment about it. So this one, do you see how it's different if it's in the denominator? So our final answer is that there. So that's a little bit different. We haven't had to move anything to the numerator yet. Are there questions there?
Nope.
I know. What's wrong, Jordan? Okay. So the first thing we did is we said negative x to the negative 4th does not have anything to subtract with, so it stayed. Y did, so we did numerator minus denominator and put it in the numerator. 5 didn't have anything to combine with, and z didn't have anything, so we stayed here. Okay, 2 negatives make a, so I added those and got negative 2 and just rewrote everything else. And then we started to look at this. This needed to move to the denominator because it's negative. Guys, I'm not just helping one person, so if you guys don't understand what you're doing, you should probably be paying attention and not talking. Do you see that y also needed to move because it was wasn't negative? 5 has an exponent of 1, so that's why it stayed. But z has a negative exponent, so it's in the denominator, so to make it positive, it needs to move upwards.
Oh, okay.
So that's like that situation when that would happen.
Yeah,
Does that make sense?
Yep.
All right. Okay, we have to do exponents on the outside first. An exponent to an exponent means we
Multiply.
Good job. I'm just going to drop everything else down. So I get x to the 10th, y to the negative 4th, and then I have negative 2, x to the negative 2nd, y to the 3rd, and negative 4x to the negative 3rd. Okay, you do not distribute over multiplication, so we're going to look at each piece. When you multiply, you do what with the exponents? So we pull out the negative 2 times the negative 4. Those are going to be in front. And we're going to add all of our x variables together. So we have 10, we have negative 2, and we have negative 3. So we're going to do x to the 10th plus a negative 2 plus a negative 3. Then we're going to look at the y's. And we're going to add those. So we have y to the negative 4th plus 3. So do you see how I looked at each variable separately and I added their exponents together? X just happened to have 3 of them this time. So negative 2 times negative 4 is negative, or it's not negative, it is positive 8. We add the exponents and we get x to the 10 minus 2 is 8. 8 minus 3 is 5. So it's x to the 5th. And y is to the... Yeah. So, Blaine, what's my final answer then?
8x to the 5th power, and then over y to the 4th power.
Y to the what?
4th power.
It would be y to the
Oh, what, first power?
first power. So that is your answer. Very good.
Good job.
I said first.
Yeah, no, you
Do not. Shh. First of all, this is a negative 1 here. So you're giving this 3 to the negative there too. So we have negative 3 times negative 1 to the 3rd. 5 times 3. 9 times 3. And then you have a to the negative 11th, b to the 6th. Negative 1 times negative 1 times negative 1 is?
Negative 1.
So this stays negative 1. A to the 15th. B to the 27th. A to the negative 11th. B to the 6th. Do not distribute that 3 in. So the other way you could have thought about this is you have, this is a negative here, right? If you have 3 negatives listed out, is that going to be positive or negative?
3 negative.
It's going to be negative because remember it has 1 that doesn't have a partner, so that makes it stay negative. So you could have thought of it that way as well. So we pull out our numbers and we'll do negative 3 times negative 1. When you multiply, what do you do with the exponents? So we have 15 plus negative 11, and we have 27 plus 6. Negative 3 and negative 1 make a positive 3. A to the 4th. B to the 33rd. Final answer or no?
Yes.
Okay, we are done.